Welcome to Lesson 8, and Lesson 8 is all about area. And when we start talking about area, we're talking about units squared. And the reason we're dealing with units squared is that whenever we divide a certain region into its square units, we notice that we end up with individual pieces, and these are supposed to be individual square units, like that one right there. This will be a 2 by 4 area, maybe 2 feet by 4 feet or 2 yards by 4 yards, and each one of these in here is 1 square yard, or square foot, or square meter, or whatever these are. Okay? 2 this way, 4 this way. So we might say a width of 2, a length of 4. And 2 times 4 gives us 1, 2, 3, 4, 5, 6, 7, 8. 8 square units. Okay. A square unit, we should point out, is 1 unit long on all sides. So it's as wide as it is tall, or as wide as it is long. Alright? Let's move on to an example. We're going to begin with rectangles. And the formula to calculate the area of a square or a rectangle is just the base times the width. Or, some of you, I'm sure before, have seen length times width, LW. It's fine. They're both fine. Just make sure you know to multiply the length times the width. So in example number 1, we have 6 times 3. That gives us 18 feet squared. Square feet. So if we were to split this up, there'd be 18 square feet inside of there. Here's another example. This one is 3 inches by 1 inch. So we have 3 times 1, and that leaves us with 3 inches squared. An important item with area problems is to make sure you always put your unit on your value. So feet squared, inches squared, whatever the unit is squared, so that everyone knows you're talking about an area. Okay, moving on to parallelograms. Their formula is exactly the same as with rectangles, and here's why. Imagine this is a parallelogram right here. See if I can draw one half decent. There we go. And I break off this piece right here, and I take away that triangle. What I'm going to do is I'm going to pick this triangle up right here and bring it over here. And if I do that, notice that I turn this parallelogram into a square. So pretend this is gone and it's now moved over to here. I've turned this parallelogram into a square. That's why their formulas are the same. They're basically the same shape. So what we have here is 15 millimeter times 7 millimeter. So all we're going to do is 15 times 7. And let's see, that would be 3 is 45, 105 millimeters squared. Okay. And this is the exact same example. So instead of doing the exact same thing over again, let's change this 7 to a 10. So we have 10 millimeter by 15 millimeter. Remember, just multiply the two together. 10 times 15, that gives us 150 millimeters. Okay? Moving on. Areas of triangles. Now, triangles can be thought of half quadrilaterals, because all the quadrilaterals we just worked with, here's a good example right here. Here's one of the quadrilaterals we just worked with. This is a rectangle or a square. Look, you can cut them in half and make triangles. Well, the formula for the area of a triangle is base times width, or length times width, times 1/2. We need the 1/2 because, look, we only have half of the area. Alright, so let's try our first example here. We have a triangle that is 3 feet by 4 feet. So we're going to do 3 times 4, but don't forget the 1/2 out front. So 3 times 4 is 12. Half of 12 is 6. And that is feet squared. Alright, our next example is 16 inches tall, 20 inches wide. Our formula is length times width, 1/2 of that. Or maybe like length times width divided by 2. Either way, it's the same thing. Okay. Let's plug our numbers in. We have 16 times 20, but don't forget to take 1/2 of that. 16 times 20 divided by 2, that leaves us with 160 inches squared. Our last example is maybe a large field. It's 4 miles tall, 5 miles wide. But don't forget, we only want 1/2 of it. So 1/2 times 4 times 5. And here's a quick way to do this. Instead of doing 4 times 5 and taking half, just take half of 4 and then multiply by 5. We could have did that over here too with this one and maybe made it a little easier. 1/2 of 16 times 20. Well, half of 16 and 8 is 8. 8 times 20 is that 160. Back to our example here. Half of 4 is 2. 2 times 5 is 10. So we have 10 miles squared, or 10 square miles. Okay, let's move on to page 2. On page 2, we have a couple composite boundaries. The first is what we call a trapezoid, and we're not quite ready to find the area of a trapezoid yet, so let's do this sort of the old-fashioned way. We're going to draw up a perpendicular, and remember, perpendicular just means a line that creates a 90-degree angle with the base down here. Perpendicular line straight down here. Now, if this is 4 and this is all 7 in here, this must be 4 here, so this has to be 3, because 4 plus 3 equals 7. Okay? This is 3, because this height is the same as this height. I'm going to calculate the area here in 2 parts, part 1 and part 2. Let's go down here and do that. Part 1 is a 3 by 4 rectangle. Remember, rectangles are calculated by multiplying the length and the width. In this case, 3 times 4, getting 12 square inches. Next, we have a 3 by 3 triangle in part 2. 3 times 3, but we only want 1/2 of that, right? So 3 times 3 is 9, half of 9 is 4.5, and that is inches squared. Add these two together for total area. This area plus this area equals total area, and that gives us 16.5 inches squared. Now remember how we added area 1 and area 2 together to get this? It's exactly the opposite whenever you have something like this. I like to call these donut problems because there's part in the middle that's missing, just like in a donut. This is a composite or put together problem. Find the area of this, find the area of this, add them. This problem is find the area of this, find the area of that, and subtract the small one from the big one. So we have 2 parts. The big rectangle outside and the small open on the inside. Okay, the big rectangle is 8 by 4. Remember, rectangles, length times width, in this case 8 times 4, 32 feet squared. From that, we're going to subtract the area of this parallelogram inside. 2 times 3 equal 6 feet squared. So final answer, I'm sorry, I should have put area 1 and area 2 on those. Now we're going to subtract these two. 32 minus 6, that leaves us with 26 feet squared. Okay, that is going to conclude our study of squares and, rectangles and triangles. Move on to video 2 for trapezoids and circles.